Good morning, good afternoon, or good night, depending on where you are. Welcome to another one of our JavaScript webinars. Today we'll be talking about the Node.js tools for Visual Studio. And what are we going to cover today? So again, it's going to be a session packed with demos. So first, a quick introduction to what the Node tools for Visual Studio are. And then probably like 15 minutes of this hour session is going to be dedicated to demos, and we'll be demoing a full developer story. So starting with writing some code in the editor, how to debug, how can we deal with our packages, we do unit testing, profiling, and so on. So basically the entire development lifecycle of building Node.js applications. So as usual, if you have any questions during this webinar or afterwards, feel free to reach out to us using the AskMSDev hashtag. Even after the webinar, feel free to post any questions you have or remarks. So let's start with Node tools for Visual Studio. So what are they? So traditionally, if you look at Windows developers, they're very often using Visual Studio, their rich integrated development environment, for doing all kinds of development, whether it's mobile development, web development, just desktop development. So they're quite used to that. However, there was kind of an area which was kind of lacking in terms of support for web development, which was specifically for Node.js development. So that was kind of the purpose of creating Node tools for Visual Studio. So it all came out of like two people in the community that built an extension for Visual Studio to allow for Node.js development to be much better than you had before. And that was kind of somewhere around 2013 when we saw the first version of the Node tools for Visual Studio. So the entire purpose of the Node tools for Visual Studio is basically to bring all of the features that you're used to from Visual Studio, bring that to Node.js development for developers that are actually developing using Visual Studio on the Windows platform. So all of the features such as IntelliSense, debugging your applications, profiling, basically all of those rich features we wanted to bring to developers on doing Node.js development while still using all of the things they like and love about Visual Studio, and all do that on the Windows platform. Now, traditionally, you'd say Visual Studio and extensions. How much does all this cost? So the Node tools for Visual Studio, it's a free extension. So as soon as you have Visual Studio, and as you may know or may not yet know, there is a free version of Visual Studio, a fully fledged version of Visual Studio, which is Visual Studio Community Edition, which you can use for free and download it. And so you can get started basically doing all of your developments for free. In combining that with this Node tools for Visual Studio extension, well, you basically have a rich editing experience for Node.js development on the Windows platform without having to pay a single penny. So this is kind of the reasons why we want to bring Node.js tools to Visual Studio, is to give you that rich experience. So as said, we're going to keep it brief in terms of presentations. One final remark I have here, and again, it's building on top of something that we've started a few years ago, is open source at Microsoft. Is that the Node.js tools for Visual Studio are, again, they're open source. They started from people in the community 2-3 years ago, and we've kind of from the beginning continued that. Initially, the Node tools were published on at the time Codeplex, which is kind of the area where Microsoft put its open source projects. Right now, you can find the Node.js tools on GitHub, as pretty much most of our open source initiatives are now hosted. So you can just go to our Microsoft Node.js tools repository, and you can find the source code. You can do pull requests. You can find all the documentation on there. If you find any bugs, issues, feature requests you have, feel free to contribute to that Git repo. So with that, let's switch to demos. So first off, let me quickly show you how do you get the node tools for Visual Studio. So we have a short link which is also included in this presentation. So you can just go to aka.ms ntvs, so node tools for Visual Studio, and this will bring us to this specific page here. We can have a link first to get Visual Studio Community, so the free version of Visual Studio that you can download here. And in addition, if you already have Visual Studio, you can just get the node tools for Visual Studio. So it's just an MSI, so an installer. Just run it, and it will add all of the node functionality into your Visual Studio deployments on your machine. The link you see here, source and documentation, this one brings you to the GitHub repository, as mentioned, to get to the source code, add pull requests, feature requests, and so on. So this is where you get started. Now, once we have that, if you launch Visual Studio Community, what you'll have here, here you already see kind of a Node.js solution open. But typically you get started by doing File, New, or Add Project. And what you'll see in there, let me zoom in a bit. So what you can see here underneath other languages, underneath the JavaScript headering here, you will see Node.js. Yeah. In Node.js, you'll see a whole bunch of templates that we have available for you to get started with a Node.js inside of Visual Studio. Let me zoom out again. So you can either start and use one of the predefined templates that we have, just a blank Node.js, or if you're using Express, we'll have versions Express 3, Express 4, and we have some alternative versions here that are already ready for you to deploy your Node.js application onto the Azure cloud platform if you'd want to. Okay, so that's your quick start. But note also that, and one that's selected here, you can also, let's say you have already done some Node.js development on Windows. You're using maybe a text editor for doing your Node.js development. Or maybe you're using Visual Studio Code, our cross-platform editor. Well, you can actually import your existing code into Visual Studio. So we'll wrap your code inside of a Node.js project, as to speak. So this will add all of the functionality that we'll see later on to your existing Node.js application. So you don't have to start from scratch. You can take an existing Node.js application and start building from there. Yeah. One thing that we've added as well is, so either you start Node.js development doing that in pure JavaScript, but as you may know, you could also leverage TypeScript for doing Node.js development. So if you go to other languages, we have TypeScript in Node.js, you'll see the exact same templates figured here. But then instead of using JavaScript, you'd be using TypeScript. Okay. So if we take an existing one, just quickly show you what wizard you go through, just to from existing Node.js code, click OK. You'll go to a wizard where you basically specify where your existing code is. And I should have here a simple Express application, which I generated using Yeoman. So I can just paste this in here. You can specify which files you want to have included in your project. We'll just do next. And basically what you get is you can specify which is your starting file, your starting JavaScript file when you have a Node.js application. When you launch your web app from the command line, you'd typically say node.exe space and then server.js or app.js just to launch your web application. Well, in here you can specify basically what your launching file is. If you'd have multiple JavaScript files, you could check it here, which one you want to use. You can go next. It will generate a Node.js project file for you, such that afterwards you'll have all of the functionality from Visual Studio added to your existing JavaScript code. So this is kind of the wizard where you go through, and it will generate basically a solution for you and a Node.js project file for you inside of Visual Studio. Just quickly cancel this one. Now, what you see here, I have a sample Node.js application. Again, the link to the GitHub repo is available in the presentation. It's basically just a simple chat room web application. So you have people that can join a chat room. They can start sending chat messages, and you have multiple people, and they can see each other's messages as they go. So a fairly simple Node.js application. It's using Socket.io for doing the WebSocket communication between the different parties, between the backend and the browser, and so on. So it's fairly simple, and it's using Express in terms of rendering and MVC model. Okay. So already what you see here, there's some code coloring inside of the editor. So inside of Visual Studio, as we browse through the code, you can see here we are rendering the index page by default. This is our routing. Here we define our Socket.io event handlers. So if a connection comes in from a browser to our backend, we can get messages for sending chat messages. If a new user gets added, we can do some functionality, and then when we have a disconnect, we'll also do some functionality. We'll see this once we start running the application. You'll see how things fit together. But this is just already showing you have some code coloring, and so basically what you expect from an editor is that it basically helps you writing code, and what Visual Studio is really strong at is giving you an IntelliSense and rich editing experience. And the same thing we want to deliver to you using Node.js. So if you, for example, start writing a new function, so already you can see I want to write a new function. Let's call that function, for example, add, because I want to create a math functionality. We want to add two numbers. So as we type, we can then, you'll see we get some IntelliSense, some hints on what is possible here. So we can return a plus b. There we go. And so we have a new function now that we've defined. So once we have defined this function, code analysis is automatically kicking in, and would have IntelliSense for this specific function already. So if you define a variable c equals, and we can say add, oops, let's do this. Check. Our code analysis is kind of lagging somewhat. We should see our add function or IntelliSense popping up, which is not right now happening. Let's just do for c add, let's say 1.2, something like this. What we'll see here is that basically something is, our IntelliSense is not kicking in here. So unfortunately can't really show you. Let's I'll just continue and see what we can do about it. It's maybe lagging just a bit, and we should see that coming up and correcting itself pretty soon. Okay, so that's basically what you would expect, is that you'd get some IntelliSense for those specific. If you add new functions, you add new variables, that you can get that IntelliSense kicking in. But also, what we can do is very often you're adding basic new packages, or you need new functionality, core functionality from Node.js inside of your code. And typically what you do, you'd say, I need to add, for example, file system functionality. You'd say for and Visual Studio's CPU is a bit blocked right now. So while we're just waiting for that one, we should see if we do require. Basically, we get already IntelliSense for our require for our packages that we want to add in here. So let's say we're looking for the file system functionality. As you see, as we type, you get also help about this package. So how do you use this one? So for fs require fs, you could do fs unlink to delete a file, and so on. Just like that, we have this functionality. If we start typing now fs dot, we get the full IntelliSense about all of the methods, the variables, the exported variables inside of our module for fs, for file system. So let's say append file. We can do this. If we start adding the parentheses, we get parameter information for this specific method. So it's this specific function requires first a file name, then some additional parameters. So you get parameter information as well as information about the specific method as well. So if we do control space on top of a function, it will just give us some description about the function, and also give us an example if that is available in the module in the code commenting. So it's going to analyze the different modules and give us that information while we're using it. So this is really handy. Comes in really handy while you're working on your code, and you're kind of discovering the different modules. So if you're using file system functionality, you don't know really what kind of methods, functions are available. IntelliSense will really help you getting started with all of that. Okay, so I just want to give it a quick retry. If we do A plus B, let's see. There we go. We finally got our IntelliSense. So what you see here is our function that we just added. We get IntelliSense, so it takes A and B parameters. If we give it 1 and 2, there we go. So what you'll see is as you are giving it specific values, because by default JavaScript and Node.js it's untyped, and A and B could take any kind of value. So as you give it specific values inside of your code, by here giving it a number value, automatically you'll get IntelliSense, and it will tell you A is a number, B is a number, and this specific function will also return a number because it can derive that from the input variables. If we were to add, for example, something like this, give it some string values, and B, what you'll notice is analysis is happening, and we'll see that variable A could be either a number or a string value. So it could be any of the two. And as well, the return value could be a number or a string. So depending on the values you give to the function, IntelliSense will analyze your code and give you more or less information depending on how methods or functions are being called. So this is also really handy. Shows you kind of the dynamic nature of IntelliSense. Okay. Now, one additional thing I want to show you in terms of editing your code in IntelliSense is what you'll see here. I'm using MongoDB. So in our chat room application, we're basically writing the chat messages in a MongoDB database. And again, if I hover on top of this connect function on our MongoDB module, it gives us the information. But one additional thing we can do is we can right click and we could say go to definition, or just use the F12 key. If you do so, it will take us immediately into the code of that specific module and put us at the position where this specific function is being defined. So like this, you can also quickly navigate and explore the code that exists. So if you have a large code base, using this go to definition functionality is really handy. Especially for people new in your code base. So F12 is really your friend if you're discovering new code. Okay, so that's kind of the basics of editing Node.js code inside of Visual Studio. So code coloring, some IntelliSense, go to definitions, the dynamic nature of parameter types. If you look at that now. Of course, there's more than just writing code. We want to run our code as well. So how do we run our code? One of the things that you have inside of your project here, if you create a new project, by default you'll have either an app.js or a server.js file, which will be marked as your startup file. What you see in here in my solution, I have multiple JS files. So how does Visual Studio know which one to launch if you want to launch your web application? So if you go to the properties, we can just right click our project and go to the properties. Just go to here, properties. What you can see in here is you can see first your path to the node executable. So it's going to look for that automatically. You can give it some additional options if you'd want to while launching your web application. And in here, so the third one is the script or the startup file, which is basically going to define which is the script I need to launch for launching your web application. And you also specify what port Node.js is going to launch at. Yeah, or going to what port you want to use for debugging. If you want to specify additional environment variables, you can do so as well in here. Yeah. So the properties of your project will allow you to set those values. Now, how do we start our application? How do we run it? So we've written our code. Well, you can just click here on this green arrow, or you could type F5 and use the F5 key. Here you could see Microsoft Edge as my browser, but you could use either Firefox or Chrome or other browsers if you have them installed. So it just really depends on your choice on where you want to launch your application in. So if I just click the Microsoft Edge and just start our Node.js application, you'll see a command window where basically your output is being put, and it's going to launch basically the application inside of your browser. So in here you could see I have an input box and I'm right now Marjorie Reynolds. I'm connected and I can start saying something. So hello there, something like this. It will display the messages. If I launch the application in another window, we'll simulate multiple users chatting. So you'll see this is a message that has been typed before in the other window. So we could say Tito is in the house, something like this. You see the message being added here. If we switch to the other window, we'll see the message also appearing here. In addition to a message where that person has connected to our chat room. So this is kind of the application, how it works. So this is basically our application while you see it running. So you see our command window where you have the output, which is streaming some debugging information and so on. Inside of Visual Studio, well, one of the key things in running your application is and developing applications is really debugging experience. So how can you look at if some things go wrong, how can you look at your code, step through your code, set breakpoints, basically the basic debugging experience. So all of that, the richness of Visual Studio is going to help us here. So we're all very much, especially if you're using Visual Studio already, you're kind of used to and you love the rich debugging experience that we have in Visual Studio. So what we're going to do now is we're going to set a breakpoint. Let's say we want to set a breakpoint when somebody sends a chat message. So how do we do this? While we're on this specific line here, this is where we have received a chat. We're going to emit that specific to chat message to different users. What we can do is either we can click in here in this gray column. You'll see a red little circle appear here, or we could just use the F9 key to toggle a breakpoint. If we do F9 and F9 again, we can toggle a breakpoint on and off. So if we do so, and we now switch to our chat room, and we can say anyone here, something like this. What we see is we're breaking into our code. Yeah. So you can see this by the yellow arrow, which is showing us the current statement that we're on. So by doing this, what we can see is we can hover over variables. So the data, this is basically our chat message that we received. If we do it like this, so we have our anyone here. We can look at the username. So this was sent by Marjorie Reynolds. So we get the full details. We can click to get more information about more richer objects. So we can get the ID of the socket and so on and so on. So we can hover over those variables. But what we can do as well, so we have a number of windows here, debugging windows available to us. So we have the locals window, where we can see local variables in the scope of our current function. So in here we have the data variable with its value that we can see immediately here, but we can also add watch variables. So we can add, for example, let's say we want to watch the socket variable. We can say add watch, and it will add it to our watch variable. We can click in here, see the different values as we go. But one nice feature that we have as well inside of Visual Studio is, let's say we want to look at this data, what is coming in here. And we don't want to switch to this window each and every time, or we don't want to hover explicitly over this variable to see its value, is we can right click and we could say pin to source. So what is happening here is the data variable is being put alongside our code. You can see it here. So as you can see here, as mentioned, I hope you still got that. So as we're stepping through our code, we get new messages. Pinning variables to the source allows us to see those variables alongside our code and just continue to see them. Just while you browse your code, you see at those specific areas in your code, you see the values. The same thing you could do here. Say username, pin to source, and we'll see it basically alongside our code if it were to exist. Okay, so we can clear those pinpoints and just continue our code. Okay. So this is basic breakpoints and debugging experiences. Now we can take it one step further. So we can configure our breakpoints. Let's say very often while you're debugging applications, in your output window, you just want to see how often do you set a breakpoint just to see the specific value of a variable. And you'd just put a console.log message inside your code just to see how a value changes over time. What we can do with that inside of Visual Studio and your breakpoints is what we can do is we can create what we call trace points. So a trace point is basically something that you say, I just want to trace the value of a variable while my code executes. But I don't want to break at that specific time. Just show me how a value, what a value is while I pass over a given line. This is what we do with if you right click on your breakpoint, just right click, you can say actions. In here you define basically what needs to happen. Yeah. So you can define an action. Let's say once we hit this specific line, I want to see the value of the username. So chat message arrived from, and then we could use the parentheses where we can say socket.username, and then we want to see the value, and let's say data, something like this. And this will allow us to kind of, as we go over this specific line, so we saved this message. So if we now execute, so we have our output window and we put a message here. So I'm doing a webinar. What you'll see is, let me just switch off this one breakpoint here, is in our output window, we see now this chat message arrived from the given person with the actual chat message in here. So trace points, really handy if you just want to see how specific values of variables change over time. Okay, so trace points, just right click, specify the action you want to take when you hit a given breakpoint. Now, an additional feature which you can see here when right-clicking on a breakpoint is conditions. So you can also have conditional breakpoints. So breakpoints, maybe you don't want to, maybe you have an issue with your code in a loop, and something happens only when you hit your loop X number of times. So for that, you can use conditional expressions. We can specify if I hit this specific line for the third time, only then you should break. Or if I filter, so for example, if I'm on a given thread, so those kind of things, you have specific conditional expressions. So where you can say if socket dot username equals let's say John Doe, only then you should break inside of the code. If you only have an issue for a given condition, you can have your breakpoints basically only hits when you have that specific condition being met. So those are kind of a more advanced features of debugging and setting breakpoints. And so let's remove this, close this here, and we can remove this breakpoint as well. So let's switch this one off and also clear our pinned value. Now, this is nice. Code is running here locally on our developer machine. Let me just stop our web application right now. What Visual Studio Code, what Visual Studio and the Node tools provide you as well is that they allow you to do remote debugging. Remote debugging not only for code that is running on Windows, but just as well you could have your, and this happens quite often, is where you have your Node.js application running on a Linux box, but you're still using Visual Studio for your development, and you basically want to remotely debug your Node.js application that is running on a Linux box. So this is something that we can do. And to show you this remote debugging functionality, basically what I'm going to show you here is, so I have a Linux box up and running here. It's running in Azure. It's just a Linux VM which has our Node.js code up in here. You can see our chat server.js, config.js, and one specific file which is of interest is the remote debug.js file. This specific file you need to put alongside your code, and this will open up a remote debugging proxy for you to connect Visual Studio to your Node.js application running on another platform. So first thing you need to do before setting up your remote debugging is just copy this remote debug.js file alongside your code onto your remote box. Where do you get this file from? So you get this file specifically from inside of Visual Studio. If you go to Tools, what you'll see in here is you have Node.js tools. We can do remote debugging proxy. If you click on Open Containing Folder, this is where the Node tools are being installed. And just open this folder. It will open up a folder where you can find this remote debug.js file. You just copy this file from here onto your remote box. Okay, so just grab this file using some remote copy tool to get it on our Linux box. This is what I've done already. And now we're going to start basically our application on our remote box. So on our Linux box, what we're going to do node. We need to do remote debug.js, and also of course, our application itself, so our chat server. We need to launch it. So just start Node on our machine. So what we're going to do now is we can connect from a browser. Let's say our would be at the IP address, and it should be available on port 3000. Connecting to this, we'll see that we are now connected. We see our same application. You'll see also debug messages appear here. We get also the list of messages that were already put in the chat room previously. They are sitting in our MongoDB database. So I can start chatting here. But what we want to do is, right now we have our application running. How can we now remotely debug into our application. So switching back to Visual Studio, what we're going to look at, so we go to the debug menu. In here we can say attach to process. So instead of just debugging doing F5, we're going to attach to a given process. In here, first thing what you do is in the transport, we're going to specify Node.js remote debugging. Okay, and in the qualifier, so where do we find our remote application? So for that, I need to copy the IP address of the remote box. So this is this specific IP address. Just copy this one. And also specify the remote debugging port number. So by default, this is 5858. Just enter. You'll see that there is an available process. So we have a node.exe, or node, basically endpoint running on that remote box. And we can attach to it. There we go. So we're attaching now. So you can see we're in the running state. And what we can do is we can now set a breakpoint. Let's set a breakpoint when a user is adding to our chat room. So we just set F9 here on socket.username. So what we can do is just refresh our page. And as you can see, so refreshing the page and we hit our breakpoint. And basically we're now remotely debugging code that is running on a Linux box. We can step through our code, we can see the values. So the username should be defined, it's Matt Moore. If we switch to our browser window, indeed, we are connected with Matt Moore. We can step to our code using F10 or 11 as we go through our code. So we have the same experience as we had for local debugging, now just for remotely debugging on a Linux box, but could just as well be any other box. Could be Windows box as well, could be another PC, could be a Mac that you're running your Node application on. This is kind of cool. Okay, so F5, and we should now have our application continuing. So F5 it again. There we go. So Matt Moore is here. We can say, hi, this is Matt. And just continue our application. In our box, you can see our chat message. So we're really connected to this Linux box. As we can see our information messages, our console showing basically our messages. Okay, so just close this one off. So remote debugging, really handy. So just recapping, what you need is this remote debug.js file. So just go to, quickly showing it again, Node.js tools, remote debugging proxy in our containing folder. You'll find this file there. Just copy it next to your code on your remote box. And then you do debug, attach the process, and you're ready to go and remotely debug your code. Okay, so this is the remote debugging. Now, one thing that you may find useful while you're writing your code is that sometimes you want to just quickly test something out. Very often you want to evaluate is the code that I'm writing here. So I was writing this new function, like the add function that I just typed there. Does it work? I want to quickly evaluate kind of how it works. And this is typically what you want to use a REPL window for. Or it's or what we call the Node.js interactive window. So where do you get this Node.js interactive window? You can go to Tools, again, Node.js Tools, and you can see the Node.js interactive window, or Control K N. As you launch this, you'll see this little window appear here, and we can check, we can define our functions here. We could just write, we could say 1 plus 2 is 3. which is kind of easy. We can define functions. Let's say our multiply. We can have a comma b. This return a times b. Again, you'll see IntelliSense coming up here. We can hover over our method. We get information about our parameters. If we do multiply, again, we'll have this IntelliSense kick in. We could say 1 times 3. Again, as we have provided it values, it now knows that a is a number and b is also a number, and multiply returns also a number. So these are kind of the things you have in this interactive window. You can write code, evaluate, does it work? Also for core modules, like for example the math module, we could say what is the value of pi? Just type something like this. All of this works in this interactive window. So while you're developing, you can immediately have this interactive environment to do some rapid coding and testing, evaluating of code. Also, interesting to know, you can also have your require. And here, if we need a file system, this also works, and then you could see your functions and so on. So you can use the require functionality also as well in this interactive window. Okay, kind of useful while you're writing your code. Okay, let's clear this one off as we go. Now, one of the things which is also interesting to know is in this interactive window is one of the core kind of features or functionalities and things that you're using while you're writing Node.js is that you'll be using a lot of packages, and you'll be using, well, typically the Node package manager, so npm, for getting those packages. One of the things in our interactive window, if we do help to get the different commands that are available to us in this interactive window, is that what you'll see is you can use the .npm kind of command inside of this interactive window to just launch npm commands. So install packages. So let's, for example, say we'll be doing unit testing in just a minute. What we could do is we could say npm install, and what we'll be using for our testing is we're going to be using Mocha. So we could say Mocha and say we want to save this one into our package.json file. So using this, our interactive windows allows us to quickly do npm installs without having to go to the command line. So you'll see here the output of an npm install Mocha on our machine here. Our package.json has changed. Do you want to reload it? Yes. And you'll see that once that finishes, what is happening right now. So you might see, wonder why is this thing waiting now? You have this spinning wheels. You'll see here on the right hand side in the Solution Explorer is that underneath the npm node, you'll see all of the packages that are right now installed for your specific application. So you'll see that Mocha was added. It's Mocha 2.4.5. It has been installed successfully, and if we click on this one here, let's see. What is happening also behind the scenes is now IntelliSense is again kicking in, analyzing the Mocha package and all the dependent packages to see what methods are available. We can open up here Mocha, and we can see also the dependent packages for Mocha. So there is the commander, we have Jade, which is their dependency. So we can have the full view of what are the packages that are installed for our specific solution, for a specific web application. So you can install it using the interactive window, using the .npm command. But just as well, you could right-click the npm node and say npl and install new npm packages, and then you'll get a UI which lists basically all of the npm packages. It gets them from the npm registry, and there you can install new packages, or you can update existing npm packages. Another way to install your packages is just by modifying the package.json file. So this is all very handy for you to use. Okay. Now, finally, we've written our code, we got our packages, we've done our remote debugging. We also need to do some testing, of course. So how can we do unit testing? So for that, as I said, we're going to use Mocha as our unit tests framework. What we can do is we could, if we right click in here, we can add a new file, a new item to our project. We can say add new item. What we're going to do is you'll see here all kinds of JavaScript items that we can add. One of them is a JavaScript Mocha unit test file. So here you'll see we can give it my tests. We say add. So the template contains basically one test suite 1, and that test suite 1 contains basically 2 unit tests. So test 1, which should be okay, it should not fail, and we also have a test 2 which has one action that should be okay, a second one which should fail. So we're asserting okay while we give it a false value. This basically should fail. Now what can we do with this? We can either use the command line and run Mocha for executing our test suite, our 2 tests. But just as well, we can use what is called the test runner inside of Visual Studio. So Visual Studio can analyze your project and it can discover unit tests inside of your project. For that, we go to Test, the Test menu. In the Windows, we can find the Test Explorer. So what's happening here? You'll see this window appear, and you can see this green bar is basically discovering now, is going through your project, trying to discover unit tests that exist. And we should see basically 2 tests, so test 1 and test 2 inside of the one test suite. And they should appear in here. So you can see them here. And what we can do now is we can run all tests. So we click the run all button. What it's going to do now is going to run Mocha for those 2 specific tests and show us the result of that. So while that is running, quickly check if there's any questions. So feel free to ask your questions using the AskMSDev hashtag. It's taking some time, probably due to the live streaming and CPU being hogged. So what you see here now, our tests have executed, and we see that we have one test which has passed, and one of the tests, so the test suite 1, test 2, has failed. If we click on it, we can just open up this window a little bit more. We can click on the output, and we can see in the output test suite 1, test 2 failed. We have an assertion error for this should fail. So if we go back to our tests, which is kind of normal because it really was supposed to fail. Now, one of the nice things is we can also, while we're running our tests, we can actually debug our tests. So not just execute them just like that, but we could say, we can right click on our test and we can say debug our selected tests. And let's say we want to put a breakpoint here because we know that this is not correct. Set a breakpoint on our assert OK. And then we debug our selected test. So while that is happening, we should hit our breakpoint so we can evaluate what exactly went wrong. Let's see if this one works okay. So it's starting up. Are we hitting our breakpoint now? There we go. So we are hitting our breakpoint, and we can see that assert OK, and we notice, well, we're testing for OK, and basically we get a false value. What we can do is we can fix this this test straight away. We can say true. If we save it and continue, it's going to rerun. Our test, and all of a sudden we can see that we have 2 passed tests. So what you saw here is we can debug our tests, and we can actually can do edit and continue. So we can, while we're editing, so while we're debugging our code, we can actually edit the code. So fix the problems that we see while debugging, and just continue our code. So what's going to happen is it's just going to relaunch basically in the block that you're in. And as you can see here, all of a sudden our two tests are now succeeding. Nice feature. The test runner as well, it's really handy to have this alongside your code. Run your unit tests on a regular basis as you go and get interaction. Even debug your tests while coding. Now, one final topic I wanna cover with you is so we've done some unit testing. Okay, this works, but sometimes, well, maybe your code it does work functionally okay. However, it's kind of slow, and you want to evaluate kind of the performance of your application. So how can we do profiling? Basically, do look at where are kind of the pain points in terms of performance in our application. For that, I want to switch to a different JavaScript file, so a different web application. So profiling.js. It's really kind of a synthetic test. So we have kind of three functions that do some math calculations. They do some square roots, and basically when we create a server, we're just going to spin up and do some calculations for big numbers. So we have some CPU happening here. Now, first thing we need to do is we need to specify that this is becoming our start page. So we want to launch our application. Profiling.js should be our startup file. So set Node.js as our startup file. If we now run our application, we should no longer have our chat room, but we should rather have our kind of synthetic tests happening. This should take a few seconds because it's doing some big calculations using some CPU. So I hope the machine can bear with me. And there you go. So we get our result. Big numbers showing here. So our calculation has happened. Now, how do we do profiling on this? Let me close this one here and this one as well. Switching back to Visual Studio. So profiling, we go to the Analyze menu, and we click on the Launch Node.js Profiling menu item. There we go. We can specify what we want to profile. So we can either profile the existing open project, but you can just as well profile an application that is running standalone outside of your project. So you just specify which script you want to launch, and we'll attach the profiler to it. Okay, so we just do start for the existing and the open project. So what is happening, it's launching now the application, and it has the profiler attached to it. So it's going to profile the code. So again, have to wait a few seconds. So our application has launched. And what you see here is now you have the Node.js performance window being open. You see that it's currently profiling. We can stop our profiling because now it's pretty much done. Our application is fairly simple. You can have more complex applications as well. As you click stop, it's going to create a report to get some analysis on the code that was running. So the report is being analyzed and generated. And what you'll see here is we get a sample profiling report. So there were a number of samples being captured while the application was running. Here you can see kind of the CPU usage. So we went up to 20-25% about what we call the hot path. You can see what are kind of the pain points inside of your code. So you can see that we see the profiling.spin1 is really being that takes a lot of CPU. It takes 38% of the time. This method alone, we can click on it. this one. Oops. There we go. So you can see for this profiling.spin, you can get a view for the specific function, what it is doing. You can see the calling function, which was spin 2. Spin 1 is not calling any other functions. So you get a view on the actual function details. Again, we can see also, for example, the call tree. So which methods or which functions are calling one another. So we can really drill down and see the different areas of our code, what is taking a lot of time, what is the hot path. Again, we can see this. It's really here, and so on and so on. So you get a number of views inside of the performance of your code, with the summary really being an interesting one and allowing you to drill down into the areas that you feel are kind of the pain points of your application. With that, we kind of covered most of the topics that I wanted to cover today. So node tools for Visual Studio. So why are they there? It's basically to kind of give you the rich experience of developing and writing code that you know from Visual Studio, bring that to developers that are using Node.js and developing that on the Windows platform. So we went through the editor with some IntelliSense. We had debugging, either local debugging and remote debugging. While you're writing your code, have the interactive window helping you to write some code, evaluate if things are correct without having to launch up the application itself. So we have the interactive window available to you. How do we deal with packages? So the NPM, installing them through different means. Then finally going into, once we've written our code, how do we unit test our code with Mocha? But yes, as well, you could use different frameworks. So we have an extensibility model so that you can use not only Mocha but different frameworks as well. And then finally, we looked a bit at profiling your code. So how can we determine if there's any performance issues with our application, and where do we find those performance issues, like using the hot path analysis. With that, there's a number of resources here. So where do you get the node tools for Visual Studio? So akms/ntvs. The link to the source code. So feel free to contribute to the node tools. We really value your feedback there. And the code for the chat room, you can find it there. So kudos to Rajan for putting that up. If you want to have more of these JavaScript webinars, just go to aka.ms/js-webinars. So as said, we'll be posting the recording of this and the previous ones also in there. So at the bottom of the Channel 9 webpage, you will find the past sessions and the recording will be in there. With that, I want to close it off. Just as mentioned, feel free to reach out to us on Ask MSDev on Twitter, either right now or anytime you have any questions or suggestions for other sessions. We'll be following up on that. Just let us know what you'd like to see if you have any questions. With that, I want to thank you and hope you can join us in next sessions. Bye.